evening. Uchita, Shubham, Vivek, good evening all. One Vivek, Chaitanya, good evening. Ritik, Rishi, what have ADC? Ash. So we will. Good evening, Rohit, Lucky, and Tupul. So how are you guys? What about your weekends? How you enjoyed? Must. Good. Studied. Deep is very good. Fine, Asif, but in home only. Yeah, lockdown on Sundays. So this is the fastest ADC. Okay, this is the fastest ADC. What is this? Class type or parallel comparator type ADC is the fastest ADC. Okay. So now let's do this. Let's implement this. In this, we are going to discuss 3-bit parallel comparator or flash type. Both are same. ADC. So we are going to discuss this one. What is that? Parallel comparator type ADC in that 3-bit parallel comparator type ADC. So now let me design it. Sorry. So Jai Hind Hindustani ji. If any lag comes, so please immediately tell me. So you have a resistor R, no Sura. You are from which branch? It is not there. Okay. You people continue for some time. I will draw the figure. especially biryani. So in the available space, I am writing. If it is not visible, kindly please adjust. If required, we can zoom later. Right, your figure is ready. So stop that discussion. Happy birthday, Sushil bhai. Okay, no problem. Celebrate. Okay, so stop. Let's come to this. So listen here. 1 minute. So this is the circuit what we call parallel comparator type ADC or class type ADC. Both are same. Now in this case, let me take the example. Here, please listen here. Please listen here. Example. V reference is equal to 8 and Vn equal to 5.5. So let me take this example and prove you how this will work. So if it is 8, by voltage division principle, you have 8 resistors, all will divide equally. Originally this is VR by 8. This will be 2 VR by 8. This will be 3 VR by 8. And this will be 4 VR by 8. This time this will be 5 VR by 8. 6 VR by 8. And this will be equal to 7 VR by 8. This is voltage division principle. Okay. If you want voltage here, total into that particular resistor by total resistance. Each resistor or total current is VR by 8R into R will give you drop of each resistor as VR by 8. So total addition will come 8 VR by 8 is finally equal to your VR or V reference, whatever. 1 minute. Okay. So suppose this is your VR or V reference in this case. Let me take. So now listen here. This is your VR you take. Good evening, Amitav. So now see here. If your Vn is, what is the Vn we have taken? 5.5. So 5. So Vn is equal to 5.5. So make all the inputs as 5.5. Your input is parallelly given to how many? 7 number of comparators. 1, 2, 3, 4, 5, 6, 7. Okay. So now this is a priority encoder with the input pin 7, 6, 5, 4, 3, 2, 1, 0. So this can be either 0 or 1. Okay, sometimes they will connect these and give it to 1. Okay, it doesn't have any effect in your response, or you can see here. Okay, I will explain this, don't worry. Now see here, 5.5 and what is my input? 5.5. Here it is 8 na, 8 in 7 VR by 8. What is this value? What is 7 VR by 8? 7 times VR is 8. 8 by 8. 7 into 8 by 8 will give you here 7, 6, 5, 4, 3, 2, and 1. Example. Okay. So now see here, this node voltage will be 7. 1 input is 5.5, another input is 7. Which one is more? 7 is more. If negative is more, you get 0. Here input is 5.5, this is 6, so 0. 5.5 is more than 5. 5.5 is more than 4, 3, 2, 1. It is more than everything. And now it is a priority encoder. Based on the highest possibility, it will give you the output. Little lag is there. Shall we change the connection? No problem. Let's change it. Today is Monday. Every Monday we have this. Is it clear? Shall I continue with this network? Okay, if any issue comes, just immediately tell me. We can change it. Right. Monday, Shankarji. No, Shankarji is very good friend of us. As usual, today for South people it is first day, but North people it started I think 2 weeks back. Yeah, I stayed in both the places. Now I know it. Right, right. So come here. Now listen here. It is a 3 to 8 priority encoder. Priority encoder means higher out of the 8 by 3 priority encoder. Very good. Okay, I think. Okay, it is a 8x3 priority encoder. Out of the 8 inputs, whichever having high priority will. So 5 to 0 all are ones. Whichever having high priority here. Which fellow is having high priority? 5 is having high priority. So 101 will come. If you apply clock, this 101 comes here also. Okay, so this is not required in the design. It is just optional. It is not compulsory. You can use some parallel input, parallel output type of register if you want. Otherwise, not compulsory. This is not compulsory. This is not mandate. Okay, because this part itself has converted your data into required format. Now listen here. Ideally, how much time is required here? What is the time required for conversion? Ideally, if you see this part, 0 clocks or 1 clock is required when if PIPO used. अगर PIPO use किया तो if I use this then 1 clock may be required. Otherwise I don't this also. This is what fastest ADC. Objective point of view. Okay. Now see here how this figure is working, how this fellow is working. Please listen here. See, nothing specified. Your priority is 7, highest priority, least priority is 0. Okay. If they specify, in this case, it should work for that case only. In this particular case. Okay. Now listen here, one more thing. Here I0 is not connected to anything because if nothing is selected by default, what is your answer? I0 is the answer. Okay. So now come here. Generally, how this fellow is working, let us understand. If your input is, yeah, it just refreshed. Okay, leave it. Refresh what? Where we are right. If your input is greater than 7 VR by 8, then what is the output I will get? That is, if your input is more than this part, this line, then you get all ones. So high priority, what is the answer? 7. Here you should give high priority to 7 only. Okay. So because when it is more than 7, it is more than 6, 5, 4, 3, everything also. You get all ones. Next, if your input is greater than 6, but less than 7, in that case you get 6 as the output. Like that, your input is greater than VR by 8, less than 2VR by 8, then you get 0, 0, 1. Last case, Vn less than or equal to VR by 8, then you get 0, 0, 0. This is how it will work. Right? So based on your input, if your input is greater than 7, you get all ones, so you get 7. Is it okay? You understand? Okay. Listen here. Here, it is one way you can say it is a simultaneous converter also. It is also called simultaneous or flash type or parallel comparator type. Why it is called parallel comparator? Because you have used these many number of comparators. Your input is given common to all of them parallelly. Output depends on input, not VR. Yeah, input is 7, you get 6 as the answer. Right. Okay, according to this, your input, I mean, this VR will decide the scale. This VR is simply you can say whatever you give here, that is divided into 8 parts. So when input comes into fits into a particular part, that particular part will come in the output. Okay, flash means spot. Okay, sudden, or you can say it is a kind of your simultaneously or flash. You will get the output here. No clock is required, no counting, no comparison, nothing is there. Right, it is like a flash, right, Ruchita? Correct. So now here one important, very important objective bit is this one. Number of comparators in n-bit flash type ADC is 2 power n minus 1. This is important objective bit. In this case, how many op amps are required? If you have 3 bit, 2 to the power of 3 is 8 minus 1. Except for last stage, you need all the cases में op amp. This is it. So here you require more op amps comparatively, but no clock, nothing is required. Here one more important point. Except in flash type ADC, in all other ADCs, we need to sample and hold. Okay, we need a sample and hold circuit at the input to sample the input and hold it up to the end of conversion. It is as simple as like a capacitor. This is your Vin. Na? Vin is a variable quantity. Okay. Normally, converter takes some time. Your input need not stay same value until the end of the conversion. So what they will do is they will first sample it and hold it by charging some capacitor or some MOSFET circuit. It will keep the input constant until the end of conversion. Like counter type ADC you take, it will count n number of clock pulses, then it will give the output. Na? Until that part, it should keep maintain your input constant. But input is, if it is not in your hand, it may be variable quantity. So what they will do, they will sample it and store it, like holding it. Then they will do the conversion. So this is true for all ADCs, but here it is not required ideally. Ideally, why it is not required? Because it is simultaneously doing the conversion. It is parallelly, fastly, no clock required. You give the input, immediately this fellow will give this, and this fellow will give this output. Ideally, 0 clocks. Okay. But here also the input capacitance of your op amp, this resistance will play some time. Okay, will play something that we discuss it. Don't worry. So let's move to the next one. No R, it is like a simple capacitor. Capacitor is instantaneously charged and kept that. When resistor is not there, it will not discharge. If resistor is there, this fellow will discharge. Then again your input will not constant. Aditya. Right? Is it clear these 2 points? Number of comparators. This is very important objective here. 1, 2, 3, 4, 5. You take anything. So that's all about flash type. Here, how to implement using normal encoder. Earlier I used a parallel encoder. Now I am giving you some time. Try this with normal encoder. Can you design this with normal encoder? What happened, Ruchita? 5 star? Okay. Right. Tell me. इसमें 5 star. Okay. Right. Tell me, please think what to do here. Okay, fine. What to do? No. Yes, Sushil. For that, what to do? that part. XOR can give, right? Listen here. Very good. So this can be directly connected. For this, you can use XOR. And here also you can use wait, XOR of these two. And here you can use XOR of these two. Seven, six, five. When suppose see here what is the advantage here is if a particular value is 1, remaining all will also be 1. Why? Because it is of designed like that. Suppose here this is your Vn. If Vn is greater than 4, it is greater than 3, 2, 1 also. Na? That is the advantage here we are having. So because of that, suppose for example, for example, your input is something like this. Okay, your 5 is 1, 1, 1. Okay, op amp gives 1 here, all ones. Okay, this is also 1. This is by default you keep 1. I not equal to 1. This is fixed to 1 forever. Okay, now you see here, these are zeros. Now initially 0 will come. 0 XOR with 0, what is the answer? 0. 0 XOR with 1, 1. 1 XOR with 1, all others will be 0. That is where your, what we call logic is. Except 5, everything is 0. So you get. Okay. Any issue is there? You want me to switch off the fan? Is it okay? Okay. Fine. Next. So that is about your parallel comparator type ADC. So let's start the questions. Very good, interesting questions are there based on this. Converters. Okay. So let's start with a small question. Definitely, Sushil. What is your doubt, Ritik? Here error depends on its step size. That is, your input is 5.5, 5.3, 5 to 6 answer is same. Let's change the thing. Wait. Okay, read. I want to take one survey. Tell me, how many of you are using laptop? I will conduct poll or desktop, whatever may be. And how many of you are using mobile? I just made right answer so that I can get some percentage. That's all. Yeah, 24% like that. So almost equal. Okay. Right. Do this question. Try this question. It is not visible. Just wait. Let me zoom. Okay. This is 3 volts. This is your V in. This is X3. Wait. This is X3, X2, X1, Y1. Okay, forget about your options. First try. It requires little time to try it first now. This is 3 volts. So what is the question? Please read first. The circuit shown in the figure works as a 2-bit ADC. Listen first. 2-bit ADC. Okay. In your V in is in the range of 0 to 3. Your input voltage is in the range of 0 to 3. Okay. So this is your V in. So now it is 3 volts. So 0.5k, 1k, 1k, 0.5k. Resistors are visible now. This is X3, X2, X1, Y1, Y0 is the output, digital output. Now you have some circuit in between. Earlier we have encoder now. Similarly, you have some circuit. Name we don't know. The MSB of the output is Y1 as expressed as a Boolean function of the inputs X1, X2, X3 is given by. What is the answer? One option is to be added. Just do it first. Forget about options for some time. First, give a try. That is 3 volts. Now it is okay now? Okay. Don't worry. X2 plus. Okay, are you ready? Now tell me the answer. function of x1, x2, x2, option B x1, option E x3, x2, x1 plus x3 bar x2, x1. So remaining guys, can I start or wait? Shall I give some hint and all? Very good. Very good. So let's start. Excellent. Right. You can see your board. Some 30% more than that given right answer. According to examiner options, more people can answer, but I gave this intentionally so that you can understand the difference of the question properly. So let's do it. One minute. I asked minimized only. Don't say I can't minimize more than that. Okay. So this is the figure given by examiner. So what we can do is your Vn is this much. By voltage division principle here, this will be 0.5. This is 1.5. This is 2.5. Just resistance voltage V into this resistance by total resistance is the formula. Otherwise, V by total impedance is 3K. Current will be 1 milliampere. Then 1 milliampere into 0.5 is 0.5. 1 milliampere into 1 is 1. 1 plus 1.5 is 1.5. Another one, 2.5. This. Okay. So if your Vin is greater than, suppose see here now, when the input Vin is, suppose this is the highest input, na? This is positive, this is negative. When in is greater than 2.5, now we have three cases. What are they? X3, X2, X1, Y1, Y0. Now, if Vin is greater than 2.5, if input is greater than 2.5, then all will be ones. Okay. Then, okay, leave that Y1, Y0. Forget about it for time being. If input is greater than 1.5 but less than 2.5, then what happens? If it is greater than 1.5, then these two people will come out as 1 and these people will come as 0. Next, if your input is greater than 1. What is that? 0.5 but less than or equal to 1.5, greater than 0.5 only, then this fellow only 1. Remaining all will be zeros. Last case, when input is less than or equal to 0.5, it is less than this also. Less than this also. Input is very low compared to 0.5 also. Then it is lower than this and this also. So all zeros will come. Everybody understand this logic up to this clear or not? Please tell me. Anyone having doubt in this? No doubt now? once you get it, now you need to design a circuit such that this is the highest input, this is the least input. Accordingly, you should give some digital values for y1 and y0. What is the best thing to do for y1 and y0? You should give this highest possibility. This is here you should give least possibility. So what is the highest possibility here? 1 1. Next 1 0 0 1. Last will be 0 0. This earlier I directly told it is an encoder. Here you are designing this circuit. Here it is in your hand only. You are only designing this circuit. Okay, once you get this table, you need to design a circuit with these are the inputs to your digital circuit. This is the output. This is the digital input. This is the digital output. This is the circuit you are going to design now. So when examiner asked y1 logic, y1 is 1 for two cases. What are they? y1 is 1 for sigma m of. Okay. Who told y1 equal to x2? It can be x1 also. Why not x1? Okay. In this, you have seen only 4 combinations. Okay, just wait. Lucky. Sigma m of. It is 1 for these 2 combinations now. 111 and 011. 3 and 7. Next. Next. Plus. 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 Tell me. Don't cares are there here. What are the don't cares for us is other than these 4, you have 8 combinations with 3 variables, but you got only 4 combinations. Huh? Remaining are called don't cares. 0 is there, 1 is there, 2 not there, 4 not there, 5 is not there, 6 not there. Why they are not there? Let me explain. What is the meaning of 6? 110. Suppose try it. 110. That is your input is more than 2.5, more than 1.5, but less than 0.5. Is there any meaning for this? Is it possible to get this condition in this circuit? No. If this is 1, because of this circuit design, the other should be, if this is 1, the upper must be compulsory 1. There is no possibility to getting bottom may 0 and top 1s. If your input is greater than 2.5, definitely it should be greater than 1.5 and also 0.5. So if 1 comes, okay, it should be like this. Okay, remaining should not come. So 111 should be there. You should not have 101 or 11. Okay, 0. This condition should not occur. Okay, so now make a K-map to implement this. X3, X2, X1. Okay, sum of the midterms 3 and 7, and what are the don't cares you are having? 2, 4, 5, 6. So 2, 4, 5, 6. Now you can make one quad. Then what is your y1? y1 equal to x2. If you don't take the don't care, what is that? It can be written as x2 into x1. Okay. If you don't take the okay, this one, it can be x2 into x1. If you write the expression individually, it is a what is that? X3 bar x2 x1 plus x3 into x2 into x1. In this case, these two are also correct only, but minimized is asked, only x2 is the right answer. Minimized form is x2. So as Lucky told here, you, by chance you can eliminate the options by seeing this also. Because 1100 here matches with 1100, you can say y1 equal to x2. That is also good observation. So everybody, is it clear? Shall we go to the next question? Okay. Shall we? Let me give you same model. One more question. Where is that digital? Right. Bhargavi, see here. 2 is a don't care. What is 2 here? Whatever not present here are don't care. Simple rule. Firstly, why it is don't care? 0, 1, 0 is don't care. What is the meaning of 0, 1, 0? Your input should be greater than 1.5. Say for example 2. It should be less than 2.5. Okay. But it should be, you should get 0 here. What does it mean? It should be less than 0.5. Is it possible your input is greater than 1.5 and less than 0.5? It is impossible. That's why that condition will never occur in this particular system. So we have taken them as don't cares. Right? Next. Try this a similar simple question. Let me also check the calculation part. It is same model. Okay. But what he asked is different. What he asked is B naught. Right, guys, start the poll. What of time I will give you? The option A is x naught into x2 x naught x1. Option B is x naught bar x2 x naught x1. Option C x naught into x2 x or x1. Next. So today 3 by 3 Harsh, very good. Ruchita, Rutik, Anuj, Mohan, Anuj 3 by 3, Mohan, Vasista, Aishwarya, Smith, Matthews, and Hussein 2 by 3. So let's do it. It is the same model question. This will be how much? Three volts. So you can make it as this is 0.5, 1.5. It is not fixed. I am making voltage division principle calculation. I am not showing. Okay. You take this if you want to find this current 3 by 100, 200, and 500 and 100, 600. Na? 3 by 6 is 0.5 milliampere. Okay. Sorry, 5 milli. 3 by 600 will be 3000 by 6. 30 by 6 is 5. Depends on the question, Aditya. In this question, if you do previous question, directly you can say from this. He asked this now. Directly you can say from this itself. It is x1 into exclusive NOR of these two. 1 minute also not required. Okay, come here. 5 milliamperes, so it will give you 5 into 100.5, and here you get 1.5, and here you get 2.5. Okay, now listen here. This is your Vn. So same story, but x3, x2, x1, x0. So if your input is greater than 2.5, when your input is greater than 2.5, input greater than 1.5, less than or equal to 2.5, input greater than 0.5, less than or equal to 1.5, input less than or equal to 0.5. I need not do it because it is the same question, you can say. But here x3 place mein you have x2, x1, x0. First case all will be 1. 1 1 0 0 sorry 0 1 1 0 0 1 0 0 0. Then what is b1 b2? Just variable names are different. 3 2 1 0. He asked b0. What is b0? He didn't minimize. You also don't minimize. x2 x1 x0 plus x2 bar x1 bar x0. It is x0 into x2 XOR with x1 whole bar according to example. That's all. B0 is 1 for this case, this case. 111 0 0. That's all. Because according to options we should go. In the options he has not minimized, we should also don't minimize. Yeah, same. It is the same question. Whatever not here, all are don't case. But we have not done minimization here. If you want to minimize the answer, you can say it is equal to sigma m of what is that? 7 and 1. 1 comma 7 plus don't case of 2 4 5 6. And add this is what x1 bar x0. For this it is x2. Okay, this is minimized. Examiner has not given this, so we do that. Right now, one very good question is coming. Get ready, guys. Ready? Read it. Don't be lazy. I will give you time. 2 minutes if you want. You can take your time. Frequency is the time between two successive samples. It is decided by your conversion time. You are also ready, Sushil? This question examiner made very nice such that every mistake will give you answer. Every mistake will give you correct answer in the options. Has given Abhinay. Okay, so come back. So now let's see how to do it. You made it, Surah. Very good. So this question is not difficult, but not easy also. Not easy in the sense you should have some patience to read it. So listen. In a n-bit flash type ADC, analog voltage is fed to simultaneously to 2 power n minus 1 comparator. Stop here. Why he should tell us? We know this now. In any n-bit flash type ADC, input is simultaneously applied to 2 power n minus 1 comparators. You know that point. Why he is saying that? So two lines are gone. The output of the comparators is then encoded into binary format using digital circuit. This also, you know, we have done this now. Output of comparators are converted into digital format. So there is a lot of story which is not required in the question. Assume that the analog voltage from here it is required, whose voltage Vin, whose output is to be converted into digital format, has a source resistance of 75. So input is having a resistance of 75. Good. As shown in the circuit below, and the input capacitance of each comparator is 8.8 picofarad. That is also good. The input must settle to an accuracy of half LSB even for full scale input change. So here he has given that your output input should read by half LSB plus or minus. Even for a full scale change means even your input changed from all zeros to all ones like that. Assume that time taken by thermometer to binary encoder is negligible. Here, while seeing this thermometer binary, you will stop studying. I mean, your mind will divert. Sir, what is thermometer code, sir? I have not studied thermometer. How it will work? This will raise your temperature, man. Okay, by reading this thermometer and all those things, it will raise your temperature. Don't raise it. Keep cool, keep calm. Okay, that examiner also not expecting from you. Examiner is not expecting from you to write that thermometer code and all those things. He used some fancy terminology, maybe from his own problem. Don't worry. Assume that the time taken by thermometer, its name is what is the job it is doing. He has given that name. Okay, to binary conversion. Okay, maybe this is coming from some RTD or thermocouple, something, some temperature sensing device. We don't mind about that. Okay, assume that time taken by thermometer to binary is negligible. Anyway, he said this time is negligible. Don't worry. If the again see here, if the flash ADC, if the flash type ADC has 8-bit resolution, this point is not required for you. Why? Already has given here 255 comparators. You know 255 means 2 power n minus 1 is n is 8. He need not give that. Which of the following alternatives is closest to the maximum sampling rate? So some redundant information is there. That's why question is lengthy. Now let's do it again. So this is the flash type ADC. All input is simultaneously, Vin is simultaneously applied to 2 power n minus 1 comparators, which is 255. So 8-bit comparator, sorry, 8-bit DAC, this one is. Okay. He is saying that input is having a resistance of 75. Input is a source is having a resistance of 75 and comparator is having a capacitance of 8 picofarad. So up to this weight. So input is like a RC circuit. Networks knowledge is required here. What is your mean? This much. Now your input is R is 75 and here you have 8 picofarad. Okay. Don't take single 8 picofarad. You should take 8 parallel with another 8 Like that, how many you should take? 255. Here, some people will commit mistake. Then you get 256 as the answer. This is the first trap. Okay. So this is how your examiner will trap you. Okay. So what is the C equivalent here is 255 into 8. Because see, this one, your input is parallelly applied to these many capacitances. Okay, forget about the value, we'll use it later. So this is your R equivalent. Okay, now, so you can write this figure as V in R equivalent and C equivalent. Okay, some people will take this also. They come from this step to this step, then they simply do small mistake. They take tau. What is tau? R equivalent into C equivalent. They calculate these two and they take F equal to 1 by tau. Okay, this is also one trap. So first step, some people will be gone. Second, some people will come to this level. At this level again, they made this. Okay, they will make T equal to R equivalent into C equivalent, and they, in that case, they get 6 megasamples. 6 megasamples. Right. You did it? I know. Some people will definitely do this. So two traps are there here. Be careful. Okay. So what to do, sir? Let me do it. If you are having good networks knowledge, some shortcut method is R equal at 5 tau system will reach steady state. At 5 tau system will reach steady state. Simply calculate 5 tau and your F equal to 1 by 5 tau is the simplest answer you can get. Approximate answer. So let me do it systematically. So this is my V naught. What is the V naught formula? From networks knowledge, 1 minus e power minus t by tau into V. This is any RC circuit voltage across the capacitor formula, 1 minus e power minus t by tau into V. Okay, final value is the input only. Okay, in this case, just wait. Is it clear? This is the equation. Up to this clear, everybody? Then we'll move to the question. Okay, Sushil. There we'll enjoy again, no problem. So now listen here. Still you will be able to understand the question. See here. What is the LSB? We know it is input voltage by 2 to the power of 8 minus 1, which is Vin by 255. Examiner want half LSB. That is half of this. What is the answer? Vin by half in 2 into 255 is 510. So your V naught should be Vin plus or minus, what is that? Half LSB. That is Vin plus or minus Vin by 510. You can say plus or minus, but you know, theoretically or practically also, whatever may be, when capacitor is, your input is Vin, your output cannot be more than Vin. Plus not possible in this case. So what is the answer? Vn minus Vn by 510. Don't take plus here. Okay. So it will give you 509 by 510 into is your V. So now you should wait until your input, I mean your V naught becomes this much value. Then only you can give the new input. That is the question. Please see. The input must settle to an accuracy of half LSB even for full scale input change. That is, inputs initially 0, it becomes Vn. Okay, then it should settle to value of what? Half LSB of its final value. In fact, we call it as a settling time also. Okay, so what is your V naught? What is your V naught? It is 1 minus e power minus t by tau into V in. This must be equal to 509 by 510 into V in. This is how you need to do this problem. Then you can cancel V in, apply logarithms both sides, find t. It will come out as 6 tau. What is tau? It is R equivalent into C equivalent. Okay, your Ts must be greater than 6 tau. That is, Fs must be less than 1 by 6 tau, which will come out as 1 mega sample per second. This will come out as 10 power minus 6. This will come out as 10 power 6. Okay. So here, instead of 6 tau, some people blindly, without any calculation, they will take at t equal to tau, it happens. No. If you take 5 tau also, there is a possibility you will get the answer. Originally, if you do this calculation by calculator, you get 6 tau as the answer. From that, you will get 10 power minus 6 as this much and 1 by 6 tau. Already you know every R equivalent, C equivalent. Simply substitute it, you will get the answer. Yes, Sura, right. Even 5 tau also, examiner is a good person, so he gave for 5 tau also one option. Okay. Otherwise, he could have made this option as 5 tau option. Even 5 tau also will give nearest answer only. That's why he also used here closest, not closed here. Who typed this? Closest to the maximum. What is that? Once your conversion is done, then only you can do the take the next sample. That's why your TS must be greater than 6 tau. Thank you, Alcha. TS must be greater than 6 tau. Lucky LSB or resolution or step size is same. Please revise the notes. This is very important. Have you attended last lecture? Doubt session? We have done n number of problems on this. Here positive Y you have not taken, Rudraksh. If you have given input, your capacitor is charging, it will reach Vn. It cannot go beyond Vn. Okay, your output cannot be more than input. In this case, I mean in this whatever you are calculating V naught is for capacitor voltage. It cannot charge beyond the input voltage. Okay, so what is the right answer? Question itself, Amitabh input must settle to an accuracy of half LSB. Okay, so now we are right. Yes, Sushil, they are my students only. They got VLSI. They are from EC. I mean, Electronics and Communication. Okay, is it clear? Shall we go to the next question? Asif, now you understand or not? It's a previous question only. Aditya. In one of the gate papers, that particular year, it is the toughest for digital. Who is Chetalal? Hello. Last year, no, Amita. It came for easy people that year. 4 questions came from digital, or the 4 questions are toughest. Okay. 16 and 17, 2 years, they gave very good questions in digital. Again, they made little easy, 1, 2 years, like that. I generally pick the questions which are very good or tricky or like that. So all different models will be available. It doesn't matter, Sushil. If it is easy, everyone will write. If it is tough, then only those who prepared will write. Okay. Thank you, Google. We'll speak on that one day. Please think. Always paper must be tough for a best prepared person. No one knows it, Jitalal. Okay, Shall, let's move. You are attending all classes or not, my dear Bao? Okay. So, what do you mean by cope up with class? You are not able to answer the poll, or you are not able to understand? You are doing job also. Fine, no problem. See, if you are see here, there are different type of students in the class. Some people have already practiced this subject earlier. Some people are having enough time to practice. Some people may not have enough time, like doing job. Some people are first time attending this course. Okay, or some people may be in the second year. Some people may be in the third year. Like that, different final year are there. Pass outs are there. So different people will have a different level of understanding. Okay, you will be able to solve the questions with enough practice. That is for sure. In the class, try to participate enough. Okay, you'll get the answer or not, never worry about it. You get the answer or not, never worry about it. Our aim is here, the mistakes you can commit. This mistake can be committed. Okay, this tau mistake can be committed. If you take only tau 6 will come. Okay, those things you should know. Okay. Rushi, all everything is available on online. All PDFs are there. Previous questions, the PDF is there. Everything is there. Thank you, Aditya. So don't worry, you are able to follow understand the class properly. That is happily enjoy that. Practice is in your hands only. If not today, tomorrow, whatever the time you feel available, you can do it. So I already told in the I think last class only. Okay, don't demotivate by seeing the polls. Some people will answer it, some people don't answer it. Okay, don't worry about it. You just keep on participating. That is the intention of the class. Okay, let's move. Okay, people want some easy question. Okay, let's have a 100% poll question. Follow your own timeline. Don't worry about the others initially. Okay, you started now. Some people started 1 year back. Some people started 6 months back. Everyone have their own timeline. You give your sincere effort. That is sufficient. So let's start the poll because some people demotivated with the last question. So I expect more response this question. Very good. I can see 100%. So finally, one who is that who made it 98? Some 5, all are in the 4. You people will make 98 or something, so I made it. I took the screenshot of 100. So finally, we make it. So the next one. Next ADC. It improves definitely hardware approximation register type ADC. Successful approximation register type ADC. Okay, so let's move. Let's move to the SAR type ADC. SAR type ADC. Yes, not register. We use some kind of register kind of circuit. That's all. Register or counter. You use flip-flop. Okay, so don't take it as resistor. That is enough. So in SAR type ADC, here compared to counter type, let's revise what we have done in counter. In the counter type, we used one up counter. It increased from 0, 1, 2, 3, 4. Like that, your input is equal to 4 or not, 5 or not, 6 or not, 7 or not. Like that, we stop after comparing each and every number. So if you have 3 bits, it will compare 0 to 7. If you have 4 bits, it will compare 0 to 15. Okay, like that, depending on the number of bits, this is what happens in what counter type it is. This is a linear search operation. That is, you are searching for this value from starting to ending, one by one, one by one, one by one. You are going. This is what we call linear search. Okay, here what is the time required? Maximum 2 power n, where with the n bits. Yes or no? If you have 2 power n here, if you have n bits 0 to 7, this part is clear or not? Please tell me. We are not talking about SAR right now. Okay, we are talking only about this first. It's like your data structure class. There also you study the similar things. So now what I will do is I will do a little modification to this searching algorithm. Instead of searching 0 to 7 sequentially, I will divide this into 2 parts. I will divide this into 2 parts. Okay. So in that, you will make it here as 0 to 3, this part as 4 to 7. That is, divide this into 2 parts. Half of the into one side, half of them into another side. Again, in this, you make half of them 0 to 1, 2 to 3. And again, half of them 0, 1, 2. So in this 4 to 7, make it half 4 to 5, 6 to 7. 4, 5, 6, 7. Like that, you should make it into half like that. Okay. Now, suppose for example, your input is the same algorithm. What is this called as binary search algorithm. Okay. So the input is binary search tree. Okay. Input is, for example, 5. Let me take the example of input is some 5. Okay, your result is 5. So first it will check, is it in this group or this group? It is in this group. Then it will come to this group. Then it will come to this group. How many steps total? 3 steps. So you can say log to the base 2 to the power of n, which will give you n. Okay, that is if it is n bits. Okay, it will take time is equal to n steps. Earlier 2 power n approximately, here n steps. Here it is not maximum. Here it is whether it is a small number or big number, any case it is fixed only. Okay, earlier if it is 1, it will stop here itself. Okay, here maximum you take. Okay, why are you worrying about that small one, Aditya? You start from 0 also. Sometimes you can count 0 also, or approximate to the nearest good value. Okay. If it is greater, you should increase the number of bits. Yes, if it is 5.4, your answer may be 5 or 6 according to the design. Then it will come to this or this, and accordingly it will go. For example, these are the outputs, system outputs. Okay, you take for example, okay, your output equal to 5. Now, no problem, na? Input can be in the range of 5.5 to 6.5, or sorry, 5.5 to 4.5 to 5.5. You take it as 5. In that case, this is the case. So finally, whatever you want, this is the result. I'm saying for result should stuck at 5 or 6 or 7. Like even it is 5.4, you answer it as a 5 or 6 only according to our system. Okay, so now see here, if it is 4, you can say 0 to 15, then you can accordingly you can divide it. Now tell me 3 steps you can do this job irrespective of your bits. So what is the advantage here? Whatever may be the data, whatever may be your output, whether your output is 0 or 1 or 2 or 3 or 4 or 5 or 6, any case, your output is coming here only. That is, it is having uniform conversion time. It requires uniform time for any input. You search anything, it will give you uniform conversion time. Okay, so it may be your data may be 0 also, that will come after 3 steps only. Yeah, n is the number of bits also. Okay, for a binary, 3 bits can do 0 to 7. So this is this thing we use in our circuit now. Which one have variable conversion time, my dear Google? For counter type, it is having variable conversion time. Yes, correct. Here it is uniform conversion time. This is used in, yes, correct. This is used in SAR. So now let's design that. Okay. So here, let me give you the block diagram, but I will explain with the help of some similar how to make this tree here. Okay. So you have the input. Your output is, say for example, 4 zeros to 4 ones. Okay, what is that? 0 to 15 in the decimal. What is half? What is the middle point we can start? What is the middle point? Like here, I took the middle point now. If it is 0 to 3 this side, 4 to 7 this side. So here 7.5 is the middle point. So you take 0 to 7 this side, 8 to 15 this side. So what is 8, sir? 1,000. Okay, 1,000. Wait. Suppose you take 3 bit. 3 bit में 3 zeros to 3 ones. It is 0 to 7. So what is the middle point? 3.5. So you can make this as 0 to 3 one side, 4 to 7 one side. What is 4, sir? What is 4, sir? What is 4? It is 100. So you can see is the initial point for comparison, or the initial value for comparison, you can say that. It must be 1 followed by all zeros must be your initial value for comparison. That is, your MSB must be 1, remaining all must be 0. Then that is the point for your comparison. Okay, you can take 0 all ones, but this is better, na, easiest one. Make MSB equal to 1, remaining all equal to zeros. That is, if it is less than this, you take it into this class. If it is more than or equal to this, you may take it into this class. That is how you should make the design. So that is how in the binary you should find your initial value of the comparison. Earlier we started with 0 0 0 0 1 2 3 linearly we went. Here we are not going like that. We are starting itself from middle. Then again here we have two parts. What is that? In this 8 to 15, 8 to 11, 12 to 15. What is 12 to 15 again? 1100. Okay, that is passing this one to here. Okay, like that, this is a continuous process if you observe it. So let's go back. Let's go to design. Okay, so here what to do is give ADC. Circuit will do, I will tell you. First, when I give start of the conversion signal, it will make first bit equal to 1, remaining all bits equal to 0. Then you get VD now. This VD and VA will be compared. VA may be greater than VD or less than VD. Accordingly, you will give either 1 or 0 here. This 1 or 0 will, you design this control circuit like that. This 1 or 0 will make the SAR such that if VA is greater than VN, sorry, if VA is greater than VD, if VA is more, it will make 1 all zeros. This it will do if VA greater than VD. If VA is less compared to VD, less than or equal to, then what it will do is it will reset this bit. That is, my input is not more than this half, it is less than this half. In that case, it will reset. Now it will make the next consecutive. These are the two choices you are having. This is the decision making circuit. Okay, this will do this job. Every case it will rotate the one like a ring counter to the next state, but it will keep the previous one or make it 0 depending on this input. Okay, it may based on, don't worry, I told Sushil, just this is a brief only, I will explain total, just wait. So this is the what happening in the circuit. Now every step we discuss it. First simple step is what? First start of the conversion. First bit is 1, remaining all bits are 0. First bit is 1, remaining all bits are 0. Okay. Then first bit is 1, remaining all bits are zeros. Now this value will go here. It will give you VD. And this will give you, this is the first step. These two will happen in the second step. Okay, first step may what happens, you get all 1 followed by all zeros. Then you get this VD value na, D to A converter value based on the step size. That VA and VD will be compared by this comparator. If VA is more, what does it mean? My input is more than this. My input is more than this. Then I will keep this one as it is. If my input is more than this, I will keep this one as it is. If my input is less, I will reset this previous bit so that my input is not more than this. In both the cases, I will shift to the next bit. I will do this operation like this up to the end of LSB. For every bit we do it. Make this one check for greater or less than. Make this one check for greater or less than. This is the story. Now let's see step by step. Let me draw it step by step. Now you can understand better. Something fusion. Okay. Stalin means Jai Hind in Hindi. Jai Hind, what is the movie name? Jai Ho. Okay. Now listen. First, okay, it is a 3-bit SAR. Okay. So first step, what you do? One, you make all zeros. Okay. This point, everybody clear or not? In the first stage, what is your job? To make input equal to 1, remaining all bits equal to 0. Next. Now listen here. Every stage have two possibilities. Go back. When you make it, VD comes. This fellow and this fellow will decide two things. Input is less or more. Carefully listen. Input is less, then make this fellow 0. Input is more, keep it. Both the cases. Next bit ko 1 karna. We should make the next bit 1. This much simple. Now ask me if you don't understand this step, because this step is repeated again. Please ask me. Whether it is doing the job or not, that is, don't worry about it. First, only this step you understand or not, ask me. Sushil, now you understand or not? First bit is made 1. I check my input is more or less. My input less, make this 0. Input is more, keep it as it is. Both the cases, next bit must be 1. I have typed these points also. I will give you that slide also. Don't. So remaining people, please tell me, up to this clear or not? Clear. Very good. Then it is very clear for you. So remaining you can understand very easily. So same story is repeated here. Okay. Listen. 0 1 is there again. This stage may which bit is recently touched. This line I made this slash like this one. Okay. So now it will check this bit whether this bit is, otherwise I will make different colors so that you can understand better. Now what I will do is, if my input is less, I will reset this. My input is more, I will keep. Okay, just wait. If input is less, first one is 1 followed by all zeros. That is fixed, because I told na middle point say we will start. First is always make 1 remaining all zeros. We start from this only. This is the starting point, SOC. Now here see. Okay, your input is less, reset this blue wala. Otherwise, keep it as it is. Both the cases, what to do? Both the cases, next bit must be made. All the cases, next bit must be 1. All the following cases, next bit must be made equal to 1. You understand here? First one, middle one, last one. This is common process. Now listen here. Again, same story. If input is less, this blue wala ko 0 kar. Otherwise, you make this blue wala as it is. Here, if it is less, keep it, make it 0. Otherwise, keep it as it is. Only 1 bit. Okay, we are touching. If it is less, make that, reset it. Otherwise, keep it as it is. If it is 1, okay. If it is less, reset. Otherwise, keep it as it is. Now you got all the 8 combinations or not? Check it. 0 to 7, Nayana. You got 0, 1, 2, 3, 4, 5, 6, 7. Okay. So now we take one input and let us see how that input is traveling from here to end. Okay, so we take one input. For that particular input, how this fellow is moving, let's check it. Shall we start that? So 3-bit means what is that triangle? If you have one more bit, you may have one more step. That's all. Number of bits increases, number of steps will increases. Here, number of steps fixed. Okay, 1, 2, 3 stages, may you will get the answer. Whatever you get after 3-step conversions, that is the final answer we take. That is MSB to LSB. You do this process. Okay, let's take one example. One minute. Uh, let's take an example of step size is equal to 1 volt and your input is 5.5. So what is VD here? Resolution into decimal equivalent is the formula. Resolution is 1, step size, decimal equivalent is 4. So this is also 2, 6, 1, 3, 5, 7. Now, okay, no problem. Now, listen here. Your input is how much? 5.5. You tell me 5.5 less than 4 or more than 4? 5.5 will be more than 4. First step may it will come to this. Now it will see what is the conversion value for this line 6. But my 5.5 is less than 6. Then it will come second step may to this condition. Now whatever my input, what is my input? 5.5. 5.5 is greater than 5 only. So finally, from the third step, you will get the answer equal to 10. Is it clear? So let me repeat. Step size is 1. These are the VD values. What is this? VD. What is this green wala? VD. Okay. So now 100 is 4. Okay, we start. Step size is equal to how much? 1. Okay, when my input at each stage, 2 possibilities are there. Yes, every stage, every bit, I mean every shift. So here first it will check. Okay, my input is greater. It will keep it as it is. Next bit go 1 karna. Next bit it will make 1. So it will get 6 as the VD. Then again it will do the same process, repetitive process. Okay, input is here less than 6. Okay, then reset this bit. Set the next bit. Same story. Here also it will check. Input is greater than 5.5. So then retain that as it is. 3 steps may you whatever you get, that is the final answer. You check for any random input, it is the same story. Let me, if you want, I can check for one more input. You tell me the value, I will check. Okay, exact integer, wait for some time. Okay, tell me something in the range of maximum here 7. Don't give beyond that. So 4.7 Aditya, 6.8. Give something less than 4 because already we checked greater than 4 na. 3.9 or 2.2. Stop it. I will take any one of them randomly. So wait. So finally, input is 2.9. I don't know who gave this. Let's try this 2.9. For 2.9, it should give 010 as the answer. 010 as the answer. So start with the input 2.9. For 2.9, 2.9 is less than or equal to 4. First step. Come here. 2.9 is greater than 2. Second step. Then 2.2, is it 2.9, is it more than 3? No. 2.9 less than. Okay, so whatever may be the input, it will follow 3 steps and give you the answer. You may think, sir, answer got it here itself. Even though he got it, it will complete all the conditions. Finally, it will give the answer. Okay, you don't know this is the final answer. So let's move to the next. If integer is there, what to do? I will tell you. Just wait. So let me give you a few points. Right. Read the points. In SAR type ADC, binary such algorithm is used when SOC is 1, MSB of the counter is made equal to 1, remaining all bits are made equal to 0. These 2 points we have already discussed, right? Next, if ADC output is less than the input signal, then the control circuit will, please see, read this, retain the previously set bit as it is. Otherwise, it will reset the previously set bit. Otherwise, it will reset previously set bit. In both the cases, next consecutive bit is made equal to 1. Whatever may be the case, input is more or less, second bit, next bit will be made equal to 1. This process will be repeated, continued up to LSB, last bit. Then end of the conversion signal is given to indicate the end of the conversion. The advantage of the SAR is, what is that? Conversion time is independent of magnitude of the input. That is, it is having uniform conversion time. Conversion time is not depending on your input strength, which is suitable for applications like DAS. We discussed DAS last lecture, data acquisition systems. Okay, so here, what is the conversion time? Is equal to n times time period of the clock, where n is number of bits, or n plus 2 if SOC, EOC included. Okay, use this if n not given. If examiner has not given n, you try this also. But it is not actually clocks. These are pulses only. But sometimes if we give, we can use this also. N plus 2. So, okay. So this is the conversion time. Here it is not maximum or minimum. It is fixed. Any input may same time. Is it okay? So all the points are covered. Here one more thing we need to discuss is, I'm sorry. I'll come to that. Just wait. Oh, your time is up. Don't worry. Because I never see the time, my 2 hours will pass easily, very easily. In exam sense, is less than input. Let's take some people already earlier asked me now you can see. Okay. So for example, this is the circuit. Okay, this is the condition. Let me take your input is equal to 2 volts. Some people earlier gave it. Okay. I load that batch also. Okay. Abhinay, at that time, those are also very good. Those networks also. See here. No, for that also I have answer. You should not ask me which batch you don't like. That is hypothetical. That I don't answer. Okay. So now see here. Now listen here. Suppose exact 2 is given. Exact 2 is given. What to do? Listen. Now it will come. Your input is 2 now. So this is your input. 2 less than or equal to 4. So what I will do is I will erase the bottom part to avoid confusion. Okay. Then now see 2 comes. Again here what is that? 2 less than or equal to 2 or 2 greater than 2. It is equal to is also coming into this only. Equal to is also coming into this class only. That is the disadvantage here. You can say even you have exact 2, you don't get 2 as the answer. What you get it in the answer? So 2 greater than 1, finally 1 as the answer. Okay, you can overcome this if you add some small value at the input. If we add offset of of LSB at input, then we can improve QE. What is QE? What is QE? Quantization error. This is what we call quantization error. Okay, we can add offset or you can subtract from this DAC also. Here, instead of VD is equal to 2, you take it 1.9, then this problem will not occur. No? So there we have added it. So here it is you can do the subtraction. That, and you see here, you should not apply a ceiling function formula here. Here you should not apply the ceiling function formula. That's why I told that formula is applicable only for which one? Counter type ADC. Here it will be lower end. Nothing is specified in the SCR. We should take the lower value. Okay, that previous is only for counter type. There it will give higher value. Okay, so depends on the design, it will change. So this you can make it by adding offset of LSB to the input or minus of LSB to DAC. This is also true. What happened, Alcha? Suppose instead of 2, you compare with 2.5. Then this problem will not occur now. You stop at 2 only answer. That's what I'm saying. So that's all for today. Problems we'll do tomorrow. Okay. Thank you very much, guys. We'll meet tomorrow. Good night, all. Sushil is having some doubt. Let me clear that. PDF, I think for only last class that problem has happened. Today it may not happen. After 2 hours of class, it will be available in this PDF. Good night, good night. So, what is this? Sushil is having some doubt. 13th question, which question? 12th question. 12th question mein minus 64 plus 60 this is in base 10, this is in base 16. So convert into base 10 first. 6 is 16, so much? 96 now. Yeah, quiz, 2 corrections are there. I will tell you tomorrow class. Okay, Asif? 2 problems I gave wrong answers. I will correct it. 96 minus 64. What is the answer? 2 and 3. So what is the question? 32. Yeah, this is 34. 42 in hexadecimal. Don't bring this. Don't please practice previous questions first, Sushil, because these type of questions will waste your time. I mean, first to do that, then you do. So in the gray code, 3 is 2. This is also not. X is 3, 6 and 5. 6 and 5 is 32. B is right answer. X is 3 may 6 and 5. Okay, this is mine 3 and 2 now. Deep, where you sent it in that group na? Sorry, I forgot it. I will check it. Don't worry. People, just wait. Let me clear this Sushil doubt. Sushil, clear हुआ आपका your doubt? Okay. So Sushil, tell me what is your doubt? Sorry, Sushil, Rahul, what is your doubt? People, but sir, if we make 2 as 1.9, I didn't get you. People, please ask clearly what you make. Ah. 1 minute, Rahul, tell me. Which numbering? Zeros and ones. I'll come to that. Rahul, I asked it there n number of times. What you are doing there? I already told na, in the single step you should ask. Then I can explain more betterly. If you stuck somewhere, which particular step you are having the doubt? At first step, I gave a pause. I asked everybody. I gave the pause. Why you didn't ask me at that time? I gave you enough freedom. You are open to ask me at that time. Okay, see here. What is the problem here is simple. First you make MSB equal to 1. Then remaining all bits are zeros. Now you should check 2 things. Your input is less or more than your DAC output. Then if input is less, you make this bit equal to 0. If input is more, keep that bit as it is. You understand? Input less, reset this. Input more, keep it as it is. Both the cases, keep the next bit 1. Both the cases, make the next bit 1. This story will be repeated here also. Now see here, in this, if input is less, this blue wala ko make it 0. Otherwise, keep it as it is. Here, blue wala ko make it 0. Otherwise, keep it as it is. Once you come here, don't touch the first bit. Okay? Only touch only one bit, that particular bit. Then, if it is less, you make it 0. Otherwise, make it 1. Both the cases, you make the next bit equal to 1. This is the way you are doing. Understand, Rahul? Okay, fine. Then Kukul. Sir, if input is 2 but offset is minus 0.1. I said half step size. I am not saying minus, plus. Kukul. See here. I told add, not subtract. Add 0.1, not subtract 0.1. I said add 0.1 to the input or subtract that half LSB to DAC. If DAC value is 1.9, your input is 2. What happens? 2 is greater than 1.9. Na? Got it? Right. So that's all for today. We can meet tomorrow. Bye bye. Good night. PDF download my dark border RNA. So dark theme. Next time when I upload the questions now, I will keep it white, and when I write it, I will make it dark. Okay, don't worry. Good night. Good night. Yeah, that is the problem when we upload the question in this. That's why generally I upload this now. At that time, I'm making white theme only. If we do this thing, I will show you. For these cases, this problem will occur. Because of that, I made this again like this. I know that. For total PDF, it won't happen. Let me download and check it, Chaitanya. No problem. Today I will try it once. Okay, send me. No problem. Thank you. Good night.